Alright, so this is my West Point Bridge project. My engineering firm name was the Smart Bridge Engineering. I'm obviously the head engineer. My bridge one, or my cheap bridge, cost efficient, was called the Raccoon River Overpass. And then my free bridge, or the non-cost efficient bridge, was the Urbandale Arch. So I'll start with the cheap bridge, the Raccoon River Overpass. So this is obviously over the river. The total ended up being about $350,000. Used a bunch of different, never really used the same material on any of the bridges. On these two, obviously those were like bearing the most weight. So I did change those to solid steel. Obviously, because if they were hollow, they wouldn't be able to bear the weight of the bridge. But I tried to play with a few things to make it still functionable and still, cost efficient. So go to the design brief here. So here's the design brief. Obviously, it's the city of Des Moines. The target consumer for my engineering firm is obviously cities and corporate companies, because no one else would be buying or trying to, make bridges. So the problem statement was, over the past years, the Des Moines metro population has increased and demand for more efficient and effective roads has come about. Therefore, the Raccoon River Overpass is here to direct and split up traffic to create more efficient yet safer alternative for cars, trucks, and motorcycles. So this is obviously the one that was cost efficient. So some of the criteria and constraints was, how to build the bridge, and what I need to build it around, considering that the Raccoon River is under me. So. So the backstory. It's kind of like in the design brief, the city of Des Moines has been rapidly growing over the past few years. Along with this growth has come an increase in traffic. Roads are getting very congested, and it's becoming a headache for drivers, causing casual delays and frustration, all until Super Jordan, the master engineer, saves the day.
Wow. Wow.
Fire? No.
Oh my.
I don't like it too much.
Should I zoom? I should zoom in on that.
My face on there.
Yeah.
Yeah. Alright. So here's the summary and cost calculation. I actually only used quench and tempered steel, solid and hollow bars for the entire bridge. Obviously, the per kilogram, the solid bar was a little bit cheaper actually, but I actually used hollow for over half my bridge. As you can see, I used way more, just because I built the outside of it with hollow tubes, and it was calculated. The base of the bridge was constructed, like I said, of solid bars due to strength and durability, with little change in the cost per material. I built the shell with 300 by 300 by 15 hollow tubes to serve as a strong shell compared to the solid steel. It's obviously, like I said, it's a trade-off. It's $1.10 more, but I was kind of willing to trade that off, to make sure my bridge was stable and was going to be able to work out. So here's the video. It's a little bendy, but I don't want it to be too bendy. Maybe a little more bendy, but so there it goes. Okay, so there's my cheap bridge. Here's my just free-for-all bridge, kinda, the Urbandale Arch. So obviously, hence the name Urbandale Arch. I had to make it, more of an arch of a bridge, especially considering the fact that it didn't have to be cost efficient. I kind of wanted to, test things out a little bit and see if I could, engineer something that could not only be efficient but look cool as well. So here, as you can see, it has the arch shape. Like my last design on the other bridge, It has the X beam patterns with beams in the middle. I just found that was, the best way to actually help the bridge hold its own weight and hold loads on top of it. It ended up being a little over $700,000. I could have made it way more expensive, but I didn't want to go too crazy on it. So design brief, same as the other one, just Urbandale, because obviously it's the Urbandale Arch, it's going to be in Urbandale. No criterion constraints. To solve the issue of Urbandale's traffic jams, the Urbandale Arch is being built to direct traffic effectively and efficiently to distribute cars better to their intended destinations, just to accommodate for the city of Urbandale's building, improve traffic flow, all that stuff. So the backstory. So Mr. Herman's drive to and from work every day are getting stressful as he would get caught up in traffic and his kids would be starving at home. You don't leave the kids starving at home. Absolutely not. Mr. Herman sent the email to the top engineer in the world and said, Des Moines, you got a problem. As you can see, from the mediocre city of Carlisle, Mr. Herman was making his drive to work. And he was very stressed out. As you can see, don't want to leave the kids starving. I came in and saved the day again, yet again. All right, so the summary cost calculation.
And all this before I grade them.
I used quenching tempered steel again, and I pretty much used all solid steel bars, as you can see. I did actually a calculation in here. It accounted, the solid steel bars accounted for 86% or almost a little over $600,000. 86%, which was 1.75 times more expensive than the first bridge, just for the solid bars. So that's like only the solid bars, 1 3/4 times more expensive than my first bridge. But obviously, this one was free. And then, like the design, helped it get the name the Urbandale Arch, just due to the fact that it's more of an arch bridge. It's not like the Golden Gate Bridge or like a flat bridge. It's like a, like the Des Moines Bridge. And yeah. So here is the load test animation for the Urbandale Arch.
I think you can build one.
So as you can see, like the solid steel bars cost like minimal bendage. Don't want to be bending too much, especially if like there's no cost constraint, right? So as you can see, these ones had tension on it, but it calls for like minimal bendage. As you can see, the first one, it was bending way in because I had to. It wasn't probably not the safest bridge, but it's the most cost efficient. So, and I think is that it? I think that's it.
All right.
All right.
Good job.